Right, so the vectors, the only things that you need to do, building on from GCSE stuff, is you've got to be able to understand and use the vector and Cartesian forms of the equation of a straight line. Use vector and Cartesian forms of the equation of a plane. That's going to be the new thing. And that's certainly been brought down from further maths to this year. That used to be FP3, you know, the hardest stuff. It says calculate a scalar product between two 3D vectors. Calculate the angle between two vectors, two lines, a line and a plane, and two planes. Again, that's going to be using quite complicated stuff. Right, understand the use of the scalar product form of the equation of a plane. That's easy. Determine whether two lines meet and determine the point of intersection. Again, easy. Calculate the perpendicular distance between two lines, a point and a line, or a point and a plane. Now that's slightly harder. That's about as hard as it gets. Okay, right. Now, just before I go on to the prior knowledge stuff, you all know that a vector, for instance, can be written as, well, as you've seen it at GCSE. If I build something from GCSE, if you see something like 3, 4, you know that means go start somewhere and go across 3 units and then go up 4 units. Okay. On top of that, that is the direction, because you start here, end there, and that can be written as vector A, and we usually write it in bold, but we can't, so we put a line underneath it. So I can say that vector A is equal to that. It is also equal to the direction O to A, for instance. Okay, so I'm just going to call that vector A. Not only that, you realise because of the triangle movement you're doing, you can find the magnitude of this by squaring that and together square rooting. That is finding the magnitude. At the moment, that has got size and direction. So to pull the size out of a vector, you mod it. And mod it, as you know, means the square of each component, like that, which will give you 5. Okay, so it's 5 units long. No. Right, here we go. I've got, beyond that now, going slightly more advanced, only very fractionally, you've got the y direction and the x direction in only 2 dimensions at this moment. You know that a unit vector, so it's got magnitude 1 in the y direction is j, we call it j, and in the x direction, 1 unit vector is called I. So we could write this column vector format that you're used to in another more typical way. This is called column format, and the next thing is A could be written as vector format. Vector format tells you how far you make this movement, which you know is 3, so we can write that as 3 i's. I gives you the direction, but it's also, I represents size 1, so I can do 3 lots of that direction because it's size 1. 3i, and obviously then plus the 4j. And I think at GCSE you've done that. No, well you have now. That's vector format. That's vector column format. Oh, yeah, yes, okay. Right, that bit there is easier to work in, but when they say they want the answers in vector format, that's what they're talking about. Okay, that example just there, let me rub it out, that A, okay, that A there is a vector. Now if I start with a, well let's go back to this, that's a vector, it can be drawn anywhere, that's the same size, that is also A, that is also A. They are all parallel and all the same size. If I go back on myself, as you know from GCSE, that is minus A. Okay, everyone happy with that? No, I'm coming on to that, so I've just drawn this. These are all vectors, okay? Now, a position vector is like a set of coordinates. This could be a set of coordinates, and you'd have to be told it's a position vector. If it's a position vector, then it must start from O, and you're going 3 and 4. So I could write that now, because it starts at the origin and finishes at A, let's say. That is vector A, and that can be now written as, or assumed as, a position vector. The next thing is, to build on that, if I call this B, okay, and B might be, as a column vector, might be something like 10, let's stick with that, 10 across and 1 up. and this one is 3 and 4. And you need to know off by heart, without even thinking about it, how you would get this vector movement. That is a vector. A to B is a vector. It's not a position vector because it doesn't start from 0. So how would you find the vector A to B? It's using the triangle law, which means if you start from A, you need to go down the known vector, which means it's a minus A, and go up this vector, which is B. And it doesn't matter what order you do it in. If I go across B and then back down A, you can see I still get to the same point. So I prefer to write that as B minus A. That is going to become very important, that triangle law. It's a very obvious one. Everyone with me so far? I could then find the size of that line by modding that answer. Everyone with me? Okay. Right. So what are these questions asking you to do? So I've got, I think, everything I need to get across at this moment in time. So coming back onto this, it says find BC given that AC is that and AB is that. So AC is starting from a point A, and wherever that's going to be, AC, A to C, let's say, C's there, and this is A to B, that's A to B. If you bring them together, then if you're trying to find B to C, which is that direction, you can clearly see you've got to go back along the AB vector, that's got to be negative, and then you're going up the AC vector. So it is simply 2, 3, and you are subtracting it from 7, 1. And that will give you this answer as a vector will be minus 5, 2. The length of it, well, I'd have to modulus that answer to find the length of it. Okay, this time, find BC, given that AB, this is in 3 dimensions, the laws still apply. Okay, if you've got AB, right, the laws for all the vectors still apply for 3D. Okay, so here we go, rubbing that out. Same scenario. I represent it as 2D because it's a lot easier. So this as a vector, as you know, just draw a 2D representation, A to B, and this one is C to A. So C to A. So it is going in that direction. Look, I've got the direction right, and that one is in that direction. They've been given us like that. So if you want to find B to C, well, I've got to go down there, B to C. So it means negative that direction, so negative of that, plus the negative version of your C vector, because you want to go A to C. So that is minus 6, 0, 3, and that gives you plus 1, plus that gives you 7, that gives you minus 5 and nothing, and that gives you minus 4 and minus 3, which is minus 7. That is the end result of that diagram, but in 3 dimensions. So a sketch, even though it's 3D, is probably always worthwhile doing it in a 2D representation to understand what, or interpret what's going on. Right, find the exact distances between the points with these. Right, you should know this, this law here. Well, you've already seen this type of law at GCSE. Okay, let me just rub that out. You should know it is, if I call that coordinate A, that coordinate B, did you know, and I hope it's a yes, it is the square root. You call one of them, it doesn't matter which one, you call one of them 1 and label the other one 2. The law says it is x2 minus x1 all squared plus y2 minus y1 all squared. You probably done it in a coordinate geometry, am I right? Okay, well, the law still applies for it. You can use these as coordinates, or you could convert them to vectors. So as a vector, you know that there it is, and these are just coordinates. I don't care where they are. I don't care if they're really there. I'm just doing a sketch to get my head around the idea. Do you agree? That could be written as a position vector, and this isn't, I don't know, I haven't even looked at these. Okay, so don't just look at the position and say, oh, they don't lie there. I'm just writing that is my vector A, that is my vector B, okay, and that is minus 1, 4. And again, if you want to find the distance between these two, let me colour that in. You want to find this distance. Well, does the direction matter? No. I could find there to there, or I could find the vector there to there, because I'm only going to find the magnitude after it anyway. Do you agree? Okay, so I'm going to do from there to there. So you don't have to, it's up to you, because you've got this rule anyway, but I just want to give you another interpretation of what's going on. Well, I'll probably generalise it in a bit anyway. So here we go. Do you agree? Going back down there and up there is that, take that. So it is minus 1, 4, take away 3 minus 2, and then I end up with that, take that, which is minus 4, sorry, not yet, and then 4 minus minus gives you plus 6, okay, so plus 6. Right, to modulus that, you are going to do minus 4 squared plus 6 squared square rooted, and that will give you the length. Let's generalize it. You ready? To show you that you get exactly the same rule. Okay? What shall I call this, do you think? To generalize it to get this exact rule. No. No. X1, Y1. Okay? This will be X2, Y2. To generalize it. Okay? And that's using X1, Y1, X2, Y2. So to generalize this in the same picture, I want to go down there, up there. So do you agree? I'm going in this direction. Can you see it will be B, which is X2, Y2, take away X1, Y1, which now gives you, on the top, X2 minus X1, on the bottom, Y2 minus Y1, and then we're going to modulus it. So modulus is the square root, after, to find the length. So you know the distance is between these two is the length between it, so you've got to square root it, because it's a distance squared otherwise, is equal to X2 minus X1 all squared, plus Y2 minus Y1 all squared. So it's the same thing whether you use vectors or coordinates. You all with me? And that applies to 3D stuff, as you know. 3D stuff, and that's where you come back to your cuboid and you find the distance between the diagonal. Yeah? Remember, it's using Pythag twice. Do you remember that rule? It is, if I call this A, this B, and this C, it boils down to A squared plus B squared plus C squared, all square rooted is the length of that diagonal. Right? You can get these distances. That distance is x2 minus x1. In general, that is y2 minus y1. And that is z2 minus z1. It still holds true. Are you all with me?
I thought it was the square root of a squared, b squared, c squared, and the square root.
It is the square root of all that.
No, it's in the square root within.
No, it's not.
Yeah,
okay. Right, I'm rubbing all that out. Okay. Right, this next bit is important, which is this bit here. Okay, it's assumed that you know it, A and B. Right, I've told you about that. What do we call this format? Vector format. Okay, I, unit vector in the x direction. J, unit vector in the y direction. K, unit vector in the z direction. To find the mod, remember, you've just done it. It is simply, mod A is simply the square root, okay? To get the magnitude, you've got to find the length of the line, right? And it is the 4 squared plus your minus 3 squared, not that you need minus, plus the 2 squared. So that will give you the root of 16 plus 9 plus 4, which is 29, isn't it? So it is root 29. That is what the size. That's what the size of it is. Okay. Can you see B? Everyone with me now? This is important. This is really important. Can you see that? That is just a what? That's just a scalar quantity. That is the size of that vector. If in that has got its direction and its size. So if I want the direction to be the same, but when I modulus it, I want the size to be 1. What do I have to do to this vector? There's the vector. What has that vector got in it? It's got that direction and it's got that size wrapped up in it. So if I divide it by its own size, what is the size of that answer? 1.
Is mod able to determine?
No. No, right? So, look, if you get the vector and you divide it by its size, do you agree? It's just 1.
Assembly's in the hall, not hall.
Hey? Hello?
Assembly's in the hall.
Assembly's
not
in the
the hall.
hall. Here's five.
Me?
That's for
No,
us.
for-
Okay.
Yeah, that's what the whole bit.
I thought I spoke fast. Right, listen. You got to get your head around this. You happy with it? There's the vector divided by its own magnitude. Its now overall answer has got a size of 1. Do you all understand that? But what has it got a direction of? It's still got the same direction. Look, because if I times each bit of this by 1 over root 29, then the I component will be 4 lots of root 29I minus 3 over root 29 lots of j plus 2 over root 29 lots of k. That has got the same direction because we're in the same ratio, same proportion as in the movements of I, j and k. But when you mod that, you'll get an answer of 1. Yeah? That's how you find a unit vector, but using the same direction. You get the vector, you divide it by its unit, its magnitude, its size. Right. I'm not going to do that last bit there. I'm just going to... No. Okay. Right, see that question 4? So the lines L1, L2 have equations, blah, blah, and bling, bling. Find the corners of the point of intersection. You just solve those simultaneously. I'm not doing that one. Okay? Right, no. I've told you everything I need you to know to go to today's lesson. Right? First lesson is nice and easy. I don't want you to read that gump, I just want you to look this way.
5 examples. 17.
I don't know, but they're all very easy. Okay? It's vectors, of course. Right! You haven't done this in mechanics. I might have explained it. I don't know. Why have I done scalar product with you?
You did it at the very first lesson.
Oh, no, because I had to show you why the matrices gave you that 0, 0, 0, why those 3 planes are either a sheaf or whatever, parallel and things like that, okay? Anyway, so I did touch on it, but I haven't done this though, so I know I haven't done this. Right, how you get, and I want you to remember this, so you've got to remain focused and look this way without looking elsewhere. Right, to find a vector equation of a straight line, to me there's no real such thing, okay? What you've got in 2 dimensions, and I keep on banging on about 2 dimensions, well, not yet, because the laws still work for 3 dimensions. It's a lot easier to just represent it very quickly in 2. Right? Now, yes, we might have a line looking like that. And there is a way of doing that. But you've got to get in your heads that the equation of this line is really a random vector, position vector that gets you from O to the line, and we call that R. I better call that capital R, right? So we need to know one point. It could be a coordinate, because we can write a coordinate as a position vector just using column vector notation. So I need one point on the line to get me to it. It can be anywhere, and then once I'm there, I need to know a vector, not a position vector. I need to know any size vector. I don't care what this vector size is, doesn't matter what it's doing, as long as its direction can go along the line. I don't care which direction it goes in, yeah, as long as it is parallel. In other words, it's got the same direction. Does that make sense? So you need to find any random point now using a fixed point. So if I call that the random point, and this is a fixed point that we definitely know lies on it, OA, So I'm going to use and call that vector A. I'm going to say that R can generally be found by starting and getting to your line and plus so many lots of lambda.
Lambda. AR.
Okay.
Does that make sense?
Yeah. Okay. Not. Sorry. AR. Yes. Okay. Right. Okay. But I'm going to call it a direction vector. Okay. So I'll put this down as B. So put these down as B's here. Okay. Don't care what, if it's going back or forth along that line, it doesn't matter. Okay. So B, and this is called your direction vector. Direction vector. This one here is called your position vector. Sorry, there it is. This is your position vector. So let me just make something up. Let's pretend that the known point as column format, 'cause it's a lot easier to write. Right, so let's pretend that's the point I want to get to, but this is the only point I know. So I go down there to get to the point, and I add to it, and let's say B is that there. So I need, I don't know, I might need 3, I might need 2 and a bit, yeah, so, yeah. And if I face this way, then I go along there, and, well, minus just turns it around. That would be a minus, do you understand? Okay. So B, now, at mechanics, when you do this in mechanics, and you will do next year, it's very similar, but this is time. The variable is time, and this is your velocity. This is the direction you're traveling, and this is velocity. You can't, so if I had this as 2, 4, do you agree? If this doesn't matter, which it doesn't matter in normal maths, core maths, do you agree, I can reduce that in a better format by pulling a 2 out and letting the lambda soak the 2 up, because lambda can stand for anything. So it's better to write that as that, do you understand? But in mechanics, you're going to get to a situation where you've got time and you've got a certain velocity you are doing. I am doing that velocity, so I can't pull 2 out because it doesn't make sense and let t soak it up. Does that make sense? Because that now saying I'm travelling at velocity that in that many, so you've got to understand when and what you're doing. Okay? So, I was just doing an example. Right. Yeah, okay. So,
do we know B?
yeah, well, that's what I'm going to give you different questions, different scenarios, what's going to allow you to work all of this out. I just want to just do one last thing here. If this is 3, 5, and say lambda is 7, then do you agree this line will be 3 plus 2 lots of that, which is 14, that will give you 17, and 5 plus 7 lots of that is 28, plus that is 23. What is that? R. That is a vector or a position vector. It's a position vector. And where does that get me? From O to the line. So can you see, whatever that is, for that line there, R equals that. That will get you, what I'm trying to show you is, is that equation of the line? Yes, that's an equation of the line. But when you put lambda into it, what are you actually finding? You're finding lambda is the variable, but you're just finding, look at the thick line I'm drawing in. You're just finding that line. Is that the equation? Is that anything to do with the line? Look what I'm drawing in. There's the line. This just gives you a point on the line. But we look at that as a vector. That's the line. Now, some of you might have misconceptions that is the equation of the line. That is just the position vector on the line. Okay, yeah. So we can tell how far that point is from the line by modding it in a way. Just understand that each one of these.
That's the vector.
Yeah. To get, so that's called the vector equation of the line.
But it's not that.
But that's not, and even that's not correct because that's the column format. So bear in mind, how do you think they're going to write it if they want the vector format? The vector format for this exact answer would be lambda there, right? Lambda there. It would be, what would the i's? It would be 3 plus 2 lambda lots of I plus 5 plus 4 lambda lots of j. Can you see I've separated to my I components and a j? This is column format, this is vector format.
How do we know what that represents when you've done lambda 2, 4 without knowing the effective gradient of the line? How would you know whether that's going to go up or
You don't.
do we not need to?
You don't need to.
Calculate?
Yeah. Okay. Because you'll only ever use in calculations where you use the random point, this random point here, for the line.
For B, why is that not minus 2 minus 4?
It could be. It could be minus 2, minus 4.
But
Because
they're the same.
yeah, because remember, lambda can stand for everything. It stand for any negative numbers, positive numbers, and decimals. Lambda can stand for any real number. So I can go back on myself by making this minus 1, for instance, which now makes the movement I'm doing minus 2, minus 4. Right? Let me come on to some questions, and then if you've got any after that, then, which I'm sure you won't have, okay? Here we go to the questions. So this question here, let me get rid of the thingamajig. Edit and clear annotation. Yes, I will. Right. Find a vector equation of a straight line which passes through point A with position vector that and is parallel to that vector. Well, that's dead easy now, I hope. Do you understand that in a sketch format, what you have... Yeah, it's only a sketch. And it's not. I'm not even looking at these sizes because it's 3D. I'm just doing it 2D. I always draw a random line looking like that. Position vector A, well, I'll choose that as A. Okay, because it says vector equation of a line with a straight line passes through the point. It passes through point A, and that as a position vector is 3 minus 5, 4. It's 3D, and I'm only representing it as 2D, but it doesn't matter. I know the direction of this line travels as a line segment, doesn't matter where that's drawn, its direction is 7, 0, minus 3. Why is there a 0 in the middle? There's no J's, that's it. Okay, so the final answer for that is R, which represents a position vector. That is, so the random point R, the general point R, is written as get me there, which is 3 minus 5, 4. And then it is plus lambda, lots of your 7, 0, minus 3, which is your direction vector. And if I could simplify that, I probably would. Okay? I can't, so I'm accepting that. That's column format, but it says vector equation format. So is that correct? No, what you should write is R is equal to 3 plus 7 lambda, brackets I, plus, and I've got, in fact, I'm not going to put plus, it's minus 5 only, isn't it? Minus 5 lots of J. Then I've got plus 4 minus 3 lambda, lots of K. That is the vector format. Okay? Just another way of writing that. It's a lot. R is a position vector to the line. So, you know, wherever you choose for lambda, it'll get you to the line for that, you know. You're getting from O to R. Yeah, well, that's it. You're going along the line, first of all, to O to A, then you're moving in the direction back and forth depending on what lambda's doing. Yeah. Okay, over the page. Nothing down there. Right, it says, and I don't know what that is, so I don't want you to remember that rubbish. You're going to have too many formulas to remember. It's not worth remembering that format. You just do a sketch and you'll get it sorted. No, just leave it. No, it's not worth crossing out. Right. Because everyone's different, you might choose to do it that way. I'm going to do it by an interpretation from a sketch. You should always do a sketch. Find a vector equation of a straight line which passes through points A, B. Bang, bing, and I just randomly put my points 2A and B, random points just there. That is A, let's call it. That is B, let's call it. And these have got coordinates, and coordinates can be just written as straight position vectors. 4, 5, minus 1, 6, 3, 2. And I'm going to draw a straight line that passes through those like such. Okay? And we've got to find the general equation of R. Okay? And that is the general point R. Well, first of all, we need a position vector. So how many options have I got? 2. And it doesn't matter. And that's why I don't want to mark at this level Because just think of how many different combinations you can have. How many different combinations can I have also of the direction vector? Where do you think I'm going to get my direction vector for this line? Not distance between A and B, I just want the vector between A and B. So exactly, I can say I want to work out direction vector first of all, the direction vector, which is either, you can choose, either, so choose got double O. Choose either A to B or B to A. It doesn't matter. And the poor examiner, Jesus, they got to be aware of all these different formats. That's why I don't like marking, as everyone knows. I'm going to do A to B. So I'm going to do A to B. I'm sticking with that. And I think if we all stick with the same, if you ever get A and B, you always do the alphabetical order. Then we'll all do it and get the same answers. So A to B. If it is A to B I want, what does it take? What is it? B minus A, because I'm going negatively down there and up there. So that is 6, 3, 2, and I'm taking away from it 4, 5, minus 1. So that will give me an answer of 6 take that is 2, 3 take that is minus 2, and 2 minus minus that gives you 3. Okay, now I've got my direction vector. I could have done it the other way, it doesn't matter. So my final answer is R. The general point R can be found by going along one of these position vectors, and it doesn't matter, and we'll always stick with the same routine. We're going to use alphabetical order. We're always going to choose A, but we could choose B. But I'm going to choose A. So it is 4, 5, minus 1, plus so many lots of any real scalar of the direction. 2 minus 2, 3. What would I always do if it's not mechanics? I would always simplify this if I could. Why can't I in mechanics again? What will this be in mechanics? Your direction comes from your velocity, and if you start tinkering with velocity, you've got problems. So you can, as long as you know what you're doing. So is that the vector equation of a straight line? No, but that we dealing in column vectors all the way through is a lot easier than dealing with i's and j's. At this stage now, it is best to write it as 4 plus 2 lambda, and that's your I direction, so 4 plus 2 lambda I, plus, and I've got my 5 minus 2 lambda j, and I've got plus my 3 lambda, because it's the positive I'm going to write first, because it just looks nicer, minus 1, lots of k. You can, yeah, you can. We always do plus, plus, plus. You are not going to lose marks, no. Right, happy with that? Okay. Right, the line, the straight line has vector equation blah blah. Okay. Right, given that the point A, B, O lies on the line, find the value of A and B. But what do I know? I know that R, okay, R represents a general point, X, Y, Z. And we know that R is also equal to, written it in column format style, in one. You would usually need to, but we're not going to, I don't think we're going to need it. All we're going to find is the value of T, then we can find A and B. Right? But sometimes you do, but it's not on this time. Right, you ready? Right? Sorry, T is T, not lambda, yeah? Exactly. So if you didn't have this prop thing, you couldn't do it, right? Well, you'd have to do simultaneous equations. But, you ready? So here we go. I have got a situation, and I'd write this as all one. So what do I mean? I would write this. Oh, sorry, that's not the same question, is it? No, it's this one, isn't it? So 3 plus t, I would write as column vector 2 minus 6t, 2 minus 6t, and minus 5 minus 2t. So that column vector has got to equal that column vector. Do you all see where all those came from? Yeah, you all understand where that came from. So now that is also equal to our specific point x, y, z is A, B, and 0. And you can see the only one we can use there is equating the z. So equate z. and you end up with minus 5 minus 2t equals 0. So clearly t, which is equal to minus 5 over 2, or 2.5. That now, like,
is AB 0 representing a point plus lambda?
A and B have to fit on the line and have to follow this proportion. It has to be so many lots of those t plus that constant, and yeah, if it doesn't follow that proportion, it won't fit on the line. So we've got the value of t to make it fit on the line, so we're going to work out what B will be with that t in it. Okay.
When I first looked at it, I saw R equals AB0 plus lambda, and then something else. Like that. Because AB0 is a point.
That's the general point around and above.
R is it? You got a straight line. You're told specifically that AB0 lies on it.
Is AB0
Is a position vector.
So why can't you do AB0 plus lambda and then something else equals to R?
AB lambda plus lambda, what's the direction, is equal to. Yeah, it doesn't matter how you do that, because you could say that's the position vector. So you could, it's not the way I would do it, and so this is the way I would do it, but you could replace that with your position vector, yeah, and put that as your x and y. I wouldn't dream of doing it, they wouldn't do that, but you'd still get the same answers.
Is T representing lambda?
T representing lambda, yes, is the variable, the parameter, sometimes called later on parametric equations.
So this is a new method to what we've been doing.
Yeah, we haven't done this type of example. We've got to show that something fits on it. So this is just building. Does it make sense or not?
So AB0 is representing a general point.
General point, general position vector, because it's a coordinate. All coordinates are position vectors. Yeah. Okay. So I can find A and B by shoving that into here first of all. So therefore, A is equal to 3 plus your minus 5 over 2, which is going to give you a half, isn't it? 2.5, yeah, half. Okay, and also therefore B is equal to 2 lots of minus 6 lots of where am I? Minus 5 over 2. So that's going to give you 2 cancels. That to give you 3, gives you positive 15. Is it 17? Okay. Right, so we've got the coordinate definitely lies on it. It is going to be half 17 0. Right, over the page, the straight line has equation blah blah. Show that another equation of the format r equals that. So we've got 2 different lines. So show that that is a different format of the equation. Right, now this is okay. Can you see that the position vectors are the same? Sorry, the direction vectors are both the same. Okay. They're just pulling a 2 out of there, so these are going in the same direction. And the next bit, show that. So I suppose you've got to show that that fits on that line. So we need to show that that fits onto this line. So if you've shown that they're going in the same direction, and as long as you've got a position vector on that line, yeah, does that make sense? So that's how I would start. It's only this type of question is only just a worded type of question. Okay, so directions are both the same. Directions both the same, i.e. 6i minus 2j. Where am I? Plus 4k implies it is 2 lots of 3i, especially to show that, minus j plus 2k. Okay, underlined. Right. Next thing is show that its position vector of one of them fits on the line of the other. So show position vector of one line, one line fits on other line. So we've got to show what value of lambda does it work for 8, 3, 1. Will that work for the general format? What's the general format of this? 2 what, plus 6 lambda. Next bit, 5 minus 2 lambda and minus 3 plus 4 lambda. Right, what am I going to use? So you tell the examiner, you equatize. Okay, so you can see that 8 equals 2 plus 6 lambda. You take 2 from both sides, divide by 6, you get lambda is equal to 1. What have you got to do with that now? You need to show that you've got to show that that works for the others. It works for the top one, but does that give me 3? Does that give me 1? So you need to tell the examiner, show works for J and K. Okay, so I'm going to put that in there. 5 minus 2 lots of 1, and that gives you 5 take away 2 is 3. Okay, and then the next one is minus 3 plus 4 lots of 1, and you can see that I've got positive 1 works. Therefore, same format, R equals position vector plus POS with an N underlined up in the air. Position vector, yeah. Okay, plus what we're talking about now, plus a scalar, lots of the same direction, direct with N in the air. Okay. You're unlikely to get that worded question like that, right? And is it what? Right, here we go quickly then. I don't need to read this, there's no need. Here we go. Right, you've seen a column vector format of an equation of a straight line. You've seen a vector equation of a straight line. You now need to work out the Cartesian format. Okay? So if you've got the generalized formula there, prove the Cartesian format. The Cartesian format looks like that. I didn't know at your age how to use that. How you can use this now, as you should know, is any pairing. You don't need to use all 3. You can use that is equal to that. That is equal to that. Doesn't matter how you know. That's how we use this Cartesian. That's a Cartesian equation of the line. So how do I get that? All you do is make, first of all, write that in its general format. So this becomes A1 plus B1 lambda. This becomes A2 plus B2 lambda. This becomes A3 plus B3 lambda. Now, for each one of these, that R represents X, Y, Z. No, it doesn't, I suppose. You can get away with it because I is just a unit vector. But here, you're just going to let X equal. So the first equation comes from X equaling A1 plus B1 lambda. You get the second one from A2 plus B2 lambda is equal to Y. And the third one is A3 plus B3 lambda, and that equals Z. And all you do now is make, and this is the trick, is make lambda the subject in each one of these. That's all you do. So it's really quick. Throw that over. X minus A1 all divided by B1 is equal to lambda. Okay. Next one is Y minus A2 all divided by B2 is your lambda. And then finally you got Z minus A3 all divided by B3 is equal to your lambda. And because these lambdas are all the same, you can equate all these. So therefore, X minus A1 over B1 must be equal to Y minus A2 all over B2, which is equal to Z minus A3 over B3. Okay? What are these? These are proportional movements that are equal to each other. What is B? B, B. These are your direction vectors. There's a lot more work at further maths, not that you have to be taught it anymore, to do with these are your directional cosines. You'll have to do that at university. It's dead easy. These are called your directional cosines. Okay, it's in your Stroud book if you got. Did I ever give you a copy of that? I did, didn't I? Right, but you use that later on. I certainly had to use that at A level. It's not in the course now. But anyway, you don't need to know that. You're away. That's how you get into Cartesian format. Don't need to remember this general formula. No one does. You just need to know how we got there. You make land of the subject. Can you see the direction vector is that, that, and that, and the position vector is that, that, and that, and your direction vector is the bottom bits. Yeah, part B. What's part B say? Hence, find the Cartesian equation of that. Right, I'm rubbing all this out. I would never, because I can't remember things. I would never remember. I don't waste my knowledge to know this, but because of speed, I'm going to go. You understand? I would do all that process again, but not in a general format. I'll be using that. So now I can just use this. Does that mean, yeah? But I would never do that, because I'm not going to remember that. No one remembers that, apart from Lewis. Okay? Right? So all you would do is put x is equal to blah, 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 make land of the subject, y is equal to blah. But I'm just going to use this now. So it is x minus the direction part of x, which is 4 over its, sorry, I keep saying that. Its position part over its direction part, which is minus 1. I'll change that in a bit. So I've got the next bit is y minus your 3 over its direction part is 2, is equal to z, and it is plus 2 over 5. Okay, I'm going to leave in that format. You could simplify that, but just for speed. Right, happy with that? Okay. You don't. I'm honest with you. I don't remember that. I've looked at it and go, oh yeah. I'll forget on it by the time I've left this room. I just know how to derive it. Next question. What are you doing?
So this is the time it's really embarrassing to all the later assembly. Then at the last one there's no seats, so it's
Okay, you lot can go, but I'm going to have to continue doing the lesson so you can pack away quietly and disappear, because this is for the rest of them. I'll do this with you lot tomorrow. Okay?
Well, we have to start the exercise now, won't we?
Oh, next lesson I suppose we can start the exercise.
No, as in tonight we'll be able to do the first 3 questions.
Yes. I could say, do you understand? I go, yes, dead easy, sir. Really well explained. That was Sasha.
Probably because that's the only one he would do.
And then I can do Amy. Sir, can you slow down? What's that P there for? I'm not too sure.
I'm good at it.
What's T plus 2?
You predicted me an A-star once, so you can't think I'm that bad.
Rightio, enjoy your assemblies. God knows what the message will be now. Mobile phones.
We have to ask permission to get our phone on.
Yeah? Or what? You can confiscate and sell them so the teacher can make more money. Sell on eBay with your expensive phones that you all carry around. Right, see you later. Yeah. I'll be starting to talk to myself now. It's going to sound stupid and tough. Right, example 6. The line L has equation R equals blah blah bling bling, and the point has position vector blah blah. Show that point P does not lie on the line. Well, there you have to do this. You write minus 2. See you later. Minus 2 plus lambda. You do 1 minus 2 lambda, and then you do 4 plus lambda. And you're going to show, does that equal 2, 1, 3? Well, obviously we can get it to fit the I, so you always equate. So equate I, and you end up with minus 2 plus lambda is equal to 2, therefore lambda equals 4. And then you're going to show that it doesn't work. So we've got 1 minus 2 lambda so I suppose you ought to formally write it down. So equate j's, you end up with 1 minus 2, and instead of lambda now I can put 4, and that will give you an answer of 8, gives you minus 7, and you can clearly say that minus 7 does not equal 1. Then equate k, and you end up with 4 plus lambda is equal to 3, and with lambda replaced with 4, you end up, sorry, not 3, you just say 8, and you'd say 8 does not equal 3. So therefore, where are we? P doesn't lie on line. Okay, next bit. Given that a circle centre P intersects L at points A and B, and that A has position vector bling bling, B, find the position vector of B. So I'm just going to rub this out, edit, clear annotation. Yes, I will. Right, so a quick sketch of this, and it's 3D. It does not matter. You just draw a random line, and there's my random line. Okay, and you know that P does not lie on the line, but there is P. Okay, and I'm drawing a circle because it looks like it cuts it twice by the sounds of it. Okay, so we got one point of crossing is A, and the other position vector B. Now the position vectors that you're after are like coordinates. They are, that is one that we've been given, and that is the other, and that is the center. Okay. So we know that this has got a position vector of P, which is 2, 1, 3. We know that the position vector of A we've been given is 0, minus 3, 6. Okay, right. So that's the question. It says find the other position vector here. Right. Now I know that this vector here is the radius of the circle, and I can also find that by going down here and up there. Okay, so I call that P. If I work out, in fact I'll go that direction, I'll go back along there and up there. So PA is equal to, and it will be A, which is 0, minus 3, 6, and it's take away P, which is 2, 1, 3. So that is now going to give you minus 2, it's going to give you minus 4 and 3. Now we're going to need the size of that. Okay, so the size of that, so we've got mod, the size of that is equal to the square root of minus 2 squared plus minus 4 squared plus 3 squared, which is 4, 16, 29, root 29. Okay, so we know that the length from here to here is 29. We know that the length from here to here is 29. Sorry, root 29. Now, we don't know that, but we know that it lies on this equation. Okay, so I'm going to write that as a general point. That as a general point would be minus 2 plus lambda. It'll be 1 minus 2 lambda, and it'll be 4 plus lambda. 4 plus lambda. And we've got to now find the length from here to here. Okay, so for instance, we could do it from there to there, it doesn't matter, but we're going to mod it. We know that the vector P to B, for instance, will equal, and it's obviously going to be this vector B, which is minus 2 plus lambda, 1 minus 2 lambda, and 4 plus lambda, and I'm going to take it away from your P, so that'll give me this direction from here to here. You've got to use the position vectors going down there and up the general point. So we're pretending that that is the general point. So it is 2, 1, 3. So that's now going to give you minus 2 plus that minus 2 is going to give you lambda minus 4. This is 1 minus 2 lambda minus that is going to give you just minus 2 lambda. And this bit is 4 plus that minus that is going to give you 1 plus lambda. So I know that vector there in that direction is that. If I modulus that, I will get the answer of what the magnitude should be. So I know that if I modulus that, so PB modded will give you the square root of your lambda minus 4, okay, that's your I component squared, plus your j component squared, plus your 1 plus lambda squared. But I know that that will equal the same as PA, which is the root of 29. So I can square both sides to get rid of the square roots, expand these out because there's no common factors, so I'm going to have to expand them out very quickly. That goes lambda squared minus 2 lots of the middle times together gives you 8 lambda, and that squared is plus 16. It's a positive, that squared gives you positive 4 lambda squared. That squared gives you 1, that times that doubled gives you 2 lambda, and that squared is lambda squared is equal to 29 because we squared both sides. Everything's going to be got over to the left hand side. I have got 5, 6 lambda squareds. I have got minus 8 plus 2 minus 6 lambda, and I've got 16 plus 1 is 17. That comes over to make minus 12. Okay, so let's check that again. 17, type that is minus 12 when it comes over, is equal to 0. Divide by 6, lambda squared minus lambda minus 2 is equal to 0. Factorize it, and you get lambda, 2 and 1, minus and a positive. So lambda could equal minus 1, or lambda could equal positive 2. Now, one of these, when they're shoved into the general format, will give you a position vector A, and the other one for lambda, whichever that might be, will give you B. So let's just check. When you put minus 1 into this format, okay, so minus 1 will give you R being minus 2, minus 1 lots of that, minus 1 is going to be minus 3. Okay, so this looks like it's coordinate B. 1 minus 1 lots of that is going to get 2, that gives you 3. And 4 minus 1 times that is minus 1, so it gives you 3. So the position vector of B must be that. Let's just check. So that must be B. So O to B must be that one there. Let's just check the other one to make sure we've got it right. Is 2. Okay, so put 2 into there. I end up with 2. So 2 times that is 2. Minus 2 times that is 0. So the other coordinate where it crosses. And put 2 into there. 2 times that is minus 4, gives you minus 3. You can see it's working. This is your A. And this is 2 into there, so it gives you 6. And you can see, yeah, this is definitely your A. So we've got the position vector of B is that. So O to B is minus 3, 3, and 3. So therefore, O to B is equal to minus 3, 3, 3. And that's it as a position vector. Okay, just checking that as a question, nothing else. Okay, it's a very typical question. We have to mod the general point. So treat B as the general point. That is very, very typical. Again, when people go wrong, it's just because they are afraid to use that as a general point. Okay.